Okay, ladies and gentlemen, we're continuing with section 2.1. I want you to notice the graph here. It's basically a line segment. The left-hand endpoint is hollow, which means it's not actually part of the set. And the right endpoint is solid, which means it is part of the set. Now that makes a very important distinction. Well, that is a distinction to make, because look what happens down here with domain. Remember when I asked you to find domain, which is the x value, you're scanning from left to right. Okay? So picture, a vertical line scanning from left to right. The vertical scan would start at 3 and it would end at 5. But notice down here, and this is very important, the reason there's an equal under the 5 but there's not one under the 3 is the 3 corresponds to where the hole was. So that's why 3 is not included but 5 is. So x is in between 3 and 5, not including 3 but including 5. Big difference. Range, the same thing. Remember, with range you always scan from bottom to top. So you're scanning. I always tell my students, hold their hands or arms horizontally and scan from bottom to top. Alright, so the bottom of the graph starts on the y-axis, or it corresponds to the y-axis of 1, and the top ends up at 3. So you see when I scan from bottom to top, I went on the y-axis from 1 to 3. But again, notice, the 1 is not included, the 3 is. The reason the 1's not included is that's where the hole was. Last question on this one, does the graph represent a function? And of course the reason the answer is yes is that we apply the vertical line test. Remember, the vertical line test gives you a yes answer if any vertical line you draw only crosses the graph one time. That means that the x value is being paired with just one y value, which is the correct way for a function to operate. Alright, let's move on. Okay, the next graph you have is a horizontal line, and it's written here for you that it extends indefinitely, but basically I could also show that with arrows. Now, to find the domain, and of course hopefully you see the reason that the answer is all reals, if you scanned a horizontal line from left to right, it would never stop, would it? It would just keep going forever in both directions. That's why the domain is all reals. The range, which is the y value, you're scanning again, remember, from bottom to top. Well, in this particular problem, the bottom and the top are pretty much the same. Notice that the y-axis, the only value you touch is 3. That's why the range is just the set containing the number 3. Does this graph represent a function? Yes. When I apply the vertical line test, any vertical line that I draw only crosses the graph one time, which means the graph is functioning properly. Remember, when the vertical line test fails, picture a circle. A circle would not represent a function. If I drew a vertical line through that circle, I could make it touch twice, and that would kill it from being a function. Okay, here we have a parabola, but this parabola opens to the side. Okay, parabolas can open up or down, to the left or to the right. Let's start with this with the question, does this graph represent a function? You can see now why the answer is no. If I apply the vertical line test, when I draw a vertical line through this parabola, it crosses twice, which means that the graph is not functioning properly. Now, domain is all your x values. Again, remember, to find domain, you scan from left to right. So in this particular picture, our scan starts at -5, and it continues getting bigger, and it never stops because the graph never stops. That's why the domain is all x values greater than or equal to -5. Now, the reason the range is all reals, these two branches of the parabola not only go out forever. But notice what happens. As you extend out, they get wider and wider and wider. So what that means is when you're scanning from bottom to top, you're virtually going from, no stopping on the bottom to no stopping on the top. That's why the answer for range is all reals. Okay. All right. We have a mapping here. And the domain is given to be the set made up of A, B, and C. The range is the set made up of X, Y, and Z. Does this mapping represent a function? Well, here's the reason it doesn't. A promises itself to be with X for forever. Okay? And then all of a sudden, A decides to go out with Y. That can't happen. Once a domain value has made up its mind, it can't change it. So basically what I'm going to say is I'm going to call A a cheater, and for that reason, this mapping is not a function. In a function, when you're looking at a function, once the X value pairs itself with a Y value, it cannot then go back and pick a different Y value. Okay.